In this assessment, we're asked to start with hydrogen sulfide and make the thioether shown using two different alkyl halides. Well, I've drawn out hydrogen sulfide in this particular way to see that what we're doing is replacing this proton with this alkyl group and this proton with this alkyl group. And presumably, since both carbons of the thioether, since this carbon is primary and this carbon is secondary, we can do this through SN2 reactions. And so let's start by deprotonating. For example, with sodium hydroxide, we'll use one equivalent to deprotonate to make the conjugate base of hydrogen sulfide. This can now do an SN2 reaction with this primary alkyl halide. We'll sketch the mechanism. Again, the lone pair donated to sigma star to give us this thiol as the product. Just to mix it up, we'll use a different base. We'll use now sodium hydride as our base. That's going to generate another thiolate anion. We can now react this thiolate anion with a secondary alkyl halide. Once again, doing an SN2 reaction, in this case, to generate the product shown. Two SN2 reactions using two different alkyl halides allows us to make the thioether.